Hello. Today we are going to solve a Nanro signpost puzzle by John Bulten. This was published on June 2nd, 2020. So we're going to solve it for educational purposes. We're not going to solve it for time. I don't think I'll go through it super quickly. It is a 2-star puzzle, so I don't think is super difficult. John Bulten is known for posting some very difficult puzzles, but this one I think is pretty easy comparatively. So let's talk about Nanro. Nanro is a genre of puzzle that I really enjoy. I think it's got good local and global logic rules to it that are very intuitive. I think they're just fun to solve. So let's talk about how we solve a Nanro. So first of all, the idea is that we want to label some cells with numbers to form a single connected group of labeled cells. So for example, this 3 right here that is in blue needs to be connected orthogonally to every other blue numbered cell that is in this grid. No 2x2 cells groups must be fully labeled. So for example, oops, wrong color. If I color all of these blue, that would be bad. So we don't want to do that. So if that happens, I'll just say because of the 2x2 rule or the square rule. So each label number, including the black given numbers, must be equal to the total count of labeled cells in that bold region, and all bold regions contain at least one labeled cell. So what that means is this region right here that has a 2 in it has to contain 2 labeled cells. So we already know one of them, which means one of these has to be a 2. This 4-cell region that has the 3 in it has to contain 3 3s, for example. And then the last Nanro rule is that you are not allowed to have 2 numbers that are the same touching each other by their sides across a region boundary. So for example, if this cell, I keep coloring the wrong color. Let's try that again. If this cell is colored, it can't be a 2. It's got to be something else. And it can't be a 3 either. So this would have to be a 1 because it's in a 1-cell region. So that's your basic Nanro rules. This is a slight variant. It's the slightest of variants, which is called a Nanro signpost. And all that does is it adds one extra rule that says that if there is a small number in the region, that tells you how many of those cells are colored. So normally we don't know we don't know what the number of the cell is unless it's got a number in it. So for example, this region has a 2 in it already, so there must be 2 labeled. What this does is it says, hey, we know that there's 2 in here, but we don't know any of them at the start. This has a cool theme to it. You'll notice that on the left side of the grid, we have normal Nanro givens. And then on the right side of the grid, it's completely mirrored, but instead of the givens, now we have a signpost clue. So we know this is a 2. Well, over here, we know this has a region of 2, but it doesn't necessarily mean that this is a 2. So those are our basic rules. So let's jump right into it. So first thing that I see is I've got a couple of 1 square cells, and I know that no regions can be empty. So I'm going to color this one, and we will throw some number 1s in there. That's not going to work, is it? I should have tested that beforehand. Okay, so let's back that up, and we will reverse the color, which is maybe what I should have done in the first place. There we go. So now if I type a 1, there we go, that's better. Oh, it's not a 2, that's a 1. And then these cells down, nope, that's wrong as well. These cells down here are going to end up being not cells that have a number in it because we already have a 1 in that cell. Okay, what else? Well, This 2 is going up against this region that also has a 2, which means that that can't be a 2, which means the 2 has to be over here. So that's the 2. So same thing with this 3. This 3 is up against this 3 region, so that can't be a 3, so those have to be the 3s. So here's a 3, and there's a 3. And then we've got a 2x2 rule here, so this is going to end up being not a number, which leaves the last one up there to be a 2. Okay, same thing over here. We've got a 2 up against this 2 region, which means that this is, oops, I keep doing the wrong color. This is going to end up being not a number, and then this has to be the 2. There's a 2 right there. And same thing here. This can't be a 2, so this one has to be a 2, otherwise they would be adjacent. Okay, so a lot of this 3 logic, oh, by the way, down here, let's say that this was a 3. Well, then that means that neither this nor this could be a 3, but then there aren't enough 3s for this region. So that cannot be a 3. That's got to be blue, which means that these are 3s. Sorry if it's not perfectly aligned. And then now this 3 we know means that this cannot be a 3, and those have to be the 3s. Yeah, that one's bad. I'm gonna, oh shoot. Oh shoot. Can I do one more? No. Okay, we'll keep it like that. Okay, so where were we? We wanted this to be a 3, and we wanted this to be a 3. Good. So a lot of the 3 logic over here, because this is a mirrored grid, is going to end up being pretty similar. These are going to end up being 1s, for example. If I could throw 1s in there. There we go. And then, yeah, the 3 logic is going to be the same over here. So if this is a 3, then these can't be 3s, but then there can't be 3 3s. There can only be 2. So this is blue, which means the other 3 are 3s. And then because this is a 3, this one can't be. So the other 3 are 3s. So that's a 3, that's a 3, and that's a 3. The 2x2 means that this can't be a 3. So those 3 are 3s. So we'll fill in a 3, 3, and a 3. And again, 2x2 logic tells us that can't be the 2, so these 2 have to be 2s. And then we've got some more 2x2 logic here, which means that can't be. Okay. Down here, we've got 2x2 logic, so we can color that blue. And then we've really got our first use of path logic. So these have to connect outwards, otherwise they'll be trapped. They want to connect to all the other purples. So we're going to color that one. And we will make this the 1. And then that can't be colored. We've probably got that in a couple more spots. But let's take a look in the center. So we don't know where any of the 2s are, but we do know that this is a 2 path, which means that if there's a 2 here, this can't be a 2. And if this is a 2, this can't be a 2. And if this is a 2, this can't be a 2. So what that leaves us with are a bunch of squares that end up having to be 2s. So that's a 2, that's a 2, that's a 2, and that, and that, and that. Okay, now these 2s are going to be trapped unless they pop out of here. So this one and this one. So that's good. Now this we know can't be a 2 because it's already touching a 2. We know it can't be a 3 because then all of these in this square right here would be filled, which means it's got to be a 1. Oh, that is not a 1. That's a 1. And then the other 2 can't be. I'm guessing it's the same logic right here. Yep. So this can't be a 3 because it would fill the 2 by 2. Can't be a 2 because it's already touching the 2. So this is going to end up being a 1. And now we can look in this corner right here. And this tells you, well, it can't be a 2 because they would have to be touching the 2, which means it's got to be a 1. And the 1 can't be here, otherwise there'd be no way out. So the 1 would have to be filled in here, and that's going to be blue. So there's a 1 there. We're going to have similar logic on the other side, I'm going to guess. So this was blue by 2 by 2 logic. Well, I don't think we're quite there yet. This 2 needs to come out. Oh, I don't know what that is yet. But it does need to come out. This is going to be blue by 2 by 2 logic. This can't be touching a 2, so that means the 2s have to be here. So there's some more 2 by 2. So there's some 2s. Good. This 2 can't touch this one, so there's got to be 2 2s down here. So there's a 2, and there's a 2. And then this 2 means that this one can't be. Okay, we've got 2 by 2 up here. We, down here, let's see. This cannot be 3. This also can't be 2. So it's got to be 1. And the question is it 1 here or is it 1 here? But it can't be 1 here, so we can make that blue. Okay, up here, same logic as over here. If this were a 2, it would be touching a 2. Can't be a 3, so it's got to be a 1, and the 1 can't be here or it wouldn't be able to get out. So the 1's got to be here, so that's blue. I keep hitting the 2 instead of the 1. Okay, now this answers the question, does it go 1 this way or 1 this way? Well, it can't go 1 this way because then it would touch a 1 again. So that would have to be blue, and this has to be purple. So this is 1 down here. Okay, now this needs to escape somehow to touch the rest of these. Can't be 3. Can't be 2 because it would be touching the 2, so it's got to be a 1. And for this one, the only way out would be to touch this one, because it can't make it out in one step going this way. So this is going to be the 1, and those will be colored blue. Okay, so now we've made it all the way down to here, and for all of this to touch, this one's going to have to end up being purple. So that's a 2. Okay, so now we've got this over here, and then we got to figure out what's going on here. So let's say that this doesn't pass through this way. Let's say that it passes down here and goes this way. So this would have to be a 2. But then if it passed through this way, this would also have to be a 2. So there's no way to get down and through here without 2 2s touching each other. And what that means for us is that it can't go this way, it's got to go this way and then up. So our other 2 is here. Okay, and then this needs to have some colored square in it, and it's got to escape. So there's got to be, oops, I keep doing the same thing. There's got to be 1 here, there's got to be 1 here. That's got to be blue by 2 by 2 rules, which means this is a 1, which means that this is going to be a 2, and then this also has to be a 2. And that leaves us with the center. So center is either 1, 2, 3, or 4. Well, it's not 1 because we already have 2. It's not 4 because they'd all be 2 by 2. It's not 2 because we're already touching a 2, which means it's got to be a 3. and it also has to exit here, which means that that's going to be colored, and that's going to be not. That's going to be blank. So we've got our last threes here, here, and here. And there is your solved puzzle. So a lot of really good Nanros out there on the internet. Signpost rule just adds a little bit of variety to them, but it really is a tiny, tiny rule. So hopefully this was educational for you, and hopefully you go out there and solve some more puzzles. Thanks.